Hey everyone, welcome to my next tutorial. Now in the previous two videos I covered the creation of our own classes, and then we instantiated instances of objects from those classes. And I also covered the use of class membership and access control modifiers. So those were keywords like static, public, and private, for example. And those allowed us to control the visibility and access to certain variables and methods within our classes. So today we're going to be putting all of that together and create a very basic coin toss game in Java. And this is going to allow us to flip a coin a certain number of times, track the number of heads versus tails, and then display the results out to us. Afterwards, we'll create a second game showing the ability to actually reuse some of our code. Now, this exercise really is going to be incorporating the previous two video lessons, but it's also going to help to show the importance of object-oriented design and the idea of encapsulation, which can greatly aid our ability towards software reuse, meaning that we can inevitably write less code and be more productive in the end. So we'll start by introducing a new concept to these tutorials, and that's the use of UML documentation for creating class diagrams in this example. So here on the screen we have this UML style documentation, and you can see here UML stands for Unified Modeling Language. And this is basically my own definition of it, but it's a standard way to graphically depict our objects and structures within our software applications. It applies to various areas such as programming, database design, entity relationships, etc. So in this case, as I said, we're going to be using it to create a class diagram, and this is going to help us model our intended coin object. This will in turn be used to help us easily translate our expected requirements into working code. And I just put here that it's language agnostic, and what that means is you can use this diagram here and give it to a C programmer, somebody who programs in Java, or somebody else who programs in PHP, for example, and they should all be able to take this and translate it into their own language code. So let's start with a basic definition of what this game is going to be, and that'll help to show how we actually get to here. So for the game, we want to show a game involving a coin that is flipped X number of times. We want to track the tally count of heads and tails, and then we want to display those results. So we need a coin. So how can we define a coin? Well, a coin, and I listed a whole bunch of bullet points here, you might have more that you would want to add, but if we go over all of these, the ones that I want to emphasize are that a coin is an object. So we're going to be creating a class to define the coin and then creating an object out of it. So that's why I just highlighted that right there. More importantly, a coin has two sides, and we label those heads and tails. So we know we need a way to track one side from the other on this coin object. And a coin can be flipped, which is something we have in our definition for the program. So we want to be able to flip it and change which side is facing up. And obviously we're going to need a way to actually tell which side is facing up after it has been flipped. So if we go back to our class diagram here, we're going to put at the top the name of the class, or the object, which is a coin. And then it's going to be made up of variables and methods. Our variables are going to hold some state information for us. So, as we said, it has two different sides, heads and tails, so we need a way to track that. Since there's only two, I can use an integer value, and the way I'm imagining it, let's say call heads 0. If it's not 0, then it must be tails. And then obviously I need another one to hold the current state information, which side is facing up after we flip it. So the methods we have, we need to, number one, be able to flip that coin. We need to be able to check which side is facing up. And then I'll just add another one, a toString method, which is going to display for us a string representation that says heads or tails. So now we can take this basic blueprint and then open up Eclipse and start to create our coin class to define this object. So if we open up Eclipse, right click, and go ahead and create a new Java project. And I'll just call this coin toss. go ahead and right click, and you can continue doing the same thing we've been doing, create a file, or in this case I'm just going to create a new class. So I'll name this coin. I don't have to add the .java because I'm using this built-in class creator inside of Eclipse. I do not want it to have the main method, so I'll uncheck that. And I'll leave everything else the same, so I'll just click Finish. So let me just jump back here. We said we needed these variables. So I need one for heads, and I also need one for the face. So I'll go ahead and I'm going to make these private. And for the heads, I'm actually going to make it a final as well. So I'm going to do private final int heads equals 0. And I'll just make a note that heads is 0, tails is 1. Now I also need another one which is going to change, so I can't make this final, but in this case I'll call it face. The currently showing side of the coin. Now, in order to make an instance of this object, I need to have a default constructor of some sort. So I'll go ahead and make a publicly accessible constructor. And I'm going to go a little further and say that whenever I create this coin, I want to randomly set the face value of it. So I'm going to call flip the second that I create this object the first time. Now you'll see here in Eclipse it gives me an error because obviously flip is undefined, and it can create this method for us. Now if I do that, the one thing to note is that this is a private method, so I won't be able to access it from anywhere outside of this class, which is not what I want. So I want to be able to flip it from my driver program later on. So I'm going to change this to being publicly accessible. And now let me just get rid of this. So now when I flip it, I need to have it switch from 0 to 1, and I don't want it to be very predictable. I want there to be some randomness to it, but we also know statistically that there's, at least theoretically, a 50-50 chance that we'll get heads and tails. So there's a number of different ways that you might imagine doing this. But one way that we want to do it, well, first of all, we want to store into this value whatever the result is. So we're going to have face equals. And now the one way that we can do this is, let's just go ahead and force that to be an integer that is returned. So this is going to be casting. We're going to use the math class, and this is going to be a statically invoked method. So we'll use math.random, and you can see over here that the random method is going to return a decimal value between 0.0 and 1.0. Well, we want 0 or 1 to show up, so we need a way to force that and only whole numbers. So if I actually go ahead and do this, and let me just show you what this is actually going to do. We know that this can return a decimal value. It's going to be between 0 and 1. So if you imagine for a second that it returns 0.45, and we multiply that by 2, that's going to give us 0.9. Well, 0.9 is the return of this portion, but then we're telling here that we want to cast this as an integer. And when we cast, what we're doing is saying essentially to truncate, to cut off everything from the decimal to the right. So if we do that, we end up with 0. So 0 gets stored into the face value, which is heads in this case. So let me take another scenario, and you can see that that'll happen for anything that is less than 0.5. So now let's say we have 0.65 is returned from math.random, and we go ahead and multiply that by 2. Well, that's going to give us 1.3. So once again, we're going to cast that as an int, which is going to truncate off this decimal and everything to the right, so we end up with 1. Since math.random can only return values that are less than 1.0, that means that we will never exceed or even reach an integer of 2, which means that we'll always be getting either a 0 or a 1 in return, which is exactly what we want. So this will actually work for what we needed to do for this purpose of having heads or tails. So again, this is going to randomly happen each time we call the flip and store it in face. So now we need a way to actually go ahead and read which side of the coin is face up. Now to do that, we could always just read the face value, but that would require our other class to have some idea of these values here, the 0 meaning heads and the 1 meaning tails, and to translate that on return. Rather than doing that, I'm going to create a method that returns a Boolean value, and I'll just check. You can either do this for heads or tails. I'll just check is heads, and this is going to return true if it is heads or false if it is tails. So I can simply, and I'll do this out the long way first, we can say if face equals heads, then I can return true, and then I could do else return false. But rather than writing all of that out, what I can just simply do is return face equals heads. And so this simple comparison is going to determine whether we return true or false. If 0 is equal to 0, this is true, and if 1 is equal to 0, this returns false. And let's just jump back here. So we have implemented both of these variables. We added our flip method, is heads, and now we just want a way to simply print out a string representation of which side of the coin is showing. So to do that, we're going to be doing public string, because we want to return a string, and then toString. And here I'm actually going to go ahead and use the ternary operation. So what I'm going to do is this comparison once again. So I'm going to do face equals heads. And again, that will check for true or false. And I'll just return like this. And I'll explain this. So here with the ternary, we have 3 different portions of this statement. The first one is going to check for a true or false. And here we do the same comparison. So if this is true, this question mark is checking this. If it's true, we execute the first case. And if this is false, we execute the second case. So if the current face is heads, we return this string, heads. And if this is false, of course, then we return this string here, which just says tails. So that sums up everything we needed to do according to our diagram. And now we just need to actually implement our program that uses an instance of this coin object. So let's go ahead here and do a new, let's go ahead and make a new class. I'm going to call this coin count, and I added an extra T, coin count. And this one is actually going to be the driver portion, so it's going to have the public static void main portion of the program. So let me just get rid of this for now. So the first thing we need to determine in this is how we want to go ahead carrying out this execution. And we're going to be tossing a coin a certain number of times. So we might want to define how many times we want to run this. For that, I'll make it a final. So let's go ahead and call this, let's get rid of that. Let's make final int flips, and let's go ahead and flip it 1,000 times for now. We need a way to track the number of heads and tails, so we're going to have an integer for heads. I'll just be a little verbose, so I'll do heads count, and then I'll do, let me initialize that to 0 actually, and let me also make one called tails count and initialize that to 0 as well. Now we're going to go ahead and make an instance of our coin object. So we'll go coin, I'll just name this coin, equals new coin. And at this point we have called the flip method, which means that our face value has already been initialized here to some random value. So now we want to run through this, and we want to actually flip the coin and tally these up a total of this number of times. So we can use our for loop to do that, and we'll start it at 1. We'll do I has to be less than or equal to our number of flips, and then add 1 each time through. And what we want to do is call the coin flip and then we simply want to check whether we need to increment the heads count or the tails count. So again, we're going to be using one of our built-in methods. We'll do if coin dot is heads. Let's do heads count plus plus. Otherwise, I'm sorry, tails count plus plus. And just to show our toString method, every time we can go ahead and do coin dot toString. So after our for loop, then finally let's go ahead and just display out all of our results. And I'll put something like, let me just separate this from the rest of our output above. I'll say the number of flips number of heads and number of tails. So now let's go ahead and run this, and I'll right click on there. I'll go down to Run As, Java Application, and I'll double click this just so we can see. Here is the result of our toString method each time. And then all the way at the bottom here we have, out of 1,000 flips, we got 513 heads, 487 tails. So we can run that again, and we keep getting different numbers each time. Actually, there we got the same as the first. 524, 476. So you can see our math.random probably isn't all that effective and is somewhat actually predictable in this case. There are other ways of generating random numbers, and there is actually a random class that we could use. But for the demonstration purposes of this, I thought that this was enough to suffice. So now I'd also said that we would go ahead and show an example of code reuse. And while this is one driver program that makes use of this coin, we can go ahead and make an entire separate one that also uses this coin object. So let me go ahead, I'm going to do this all within the same project in the same package, which later on you'll see that it is not usually recommended, but let's go ahead and just create a new class. And in this one I'm going to call this coin race. It's also going to have the main method. So let me take all of this back. And so for this, what we're going to do is actually create two coins from our coin class, and then we're going to continually flip them until one of them comes up heads 3 times in a row. And then that one would be declared the winner, I guess you could say. So let's go ahead and start by defining our goal state, which is 3 in a row. We need to keep track of the count for each coin, so we're going to do count 1 will initialize to 0, and count 2 will also initialize to 0. And now we need 2 separate coin objects. So we'll do coin 1 equals new coin. And this may seem a little sloppy to you, and you can go ahead and just do separate lines, but this is a possible way to create 2 separate coin objects. Here we're calling that we're going to be using this coin class. We're naming the first variable or object coin 1, and then we're using the new keyword to call its constructor, and then we're just defining the second coin object and using the new keyword again to call the constructor once again. So this time I'll use the while loop because we want to continue until at least we reach the goal state. So we want to say while count 1 is less than our goal. And let me just keep these nice and organized together. So while that is true, now you have two options. We can use an AND situation here or an OR situation. So in this case, what we're saying, as long as count 1 is less than goal and count 2 is less than our goal state, well, in that situation, we want to continue looping through this program. Alternately, what I could do is while I could do a do while, and I could also make use of an OR, but I'll leave that out for this. This seems a little bit more straightforward for right now. So I'll do coin 1, and we're going to flip it, and we're also going to do coin 2, flip. Now we'll print out the value of each one, so we'll say coin 1 is now this is a somewhat of a strange situation here because we're not actually telling it to run any method, we're just telling it to print out the value of coin 1 essentially. But when we do this here, what's really happening is it's going into this coin class and it's using the toString method. Technically, this is actually an override method. If we were to actually leave this code out and call this, we would see some kind of weird string of something that might look, I don't know, like that. And what that is really is an object reference. It is the way that the Java virtual machine is actually addressing the location in memory of this object. It's what's known as an object reference. So at any rate, I thought I should just point out that distinction. What we could do to really emphasize what's going on is go ahead and just call the toString method. But if we omit it, in this case, it's going to call this anyway. So let's do the same thing for coin 2. And now we need to determine whether we need to increment our counters or set them back to 0. Again, we want 3 in a row, so if we get 2 in a row and the third one comes up and it's not heads, then we need to reset that back to 0. So to do that, we'll just work on the first coin for a second. So count 1 is going to equal coin 1 is heads. Here we're going to be using our ternary operator once again. So we'll say in this case, check the status of that, and then if it is heads, then we can do count 1 plus plus. I'm sorry, we can't do plus plus because we're actually assigning something into here. So we have to do count1 plus 1, and otherwise we want to assign it to 0. So let me go back over this once again. We're going to do a ternary operator. We're checking the status of this. So if it is heads, then we execute this first one. So if this is true, we execute this first one, which means take whatever the current count is and add 1 to it and store it inside itself. If this comes back false, we jump to after the colon, so we're going to take 0 and store it into count 1. So if count 1 is currently 2 and this comes up true, we're adding 1 to it. Now this is going to be 3. If this is 3, it's no longer less than our goal. It's actually equal to our goal. And this while loop would then terminate. So now we need to do the exact same thing for our second coin. So I'm going to copy and paste. Just make sure that you change everything appropriately. So we want our count 2, and this is going to be for our coin 2. And now finally, if we do actually exit our while loop, so let me just put end while loop, that means somebody has won. At this point we want to print who won the game, so we can just use a simple series of if statements. If count 1 is less than goal, then we know that the second coin won. Otherwise, and let's just check for this anyway, count 2 is less than goal. Then we also know that, oops, coin 1 wins. And the reason why I checked for this a second time is because we should at least handle the possibility that we might get a tie. And in that case, we'll print it was a tie. So let's go ahead now and right-click on Coin Race, run as. So here we got coin 2 won, because if we trace this back, coin 2 received heads, heads, and heads there 3 in a row. So let's go ahead and run it again. Coin 1, coin 2, and there we actually got a tie situation. So you always have to be aware that in some situations you may overlook a possible outcome. And later on you might actually want to implement this using some kind of threading where each coin gets flipped in its own thread and then reported back. So the last thing I'm going to do here, and this is just a general practice that I like to do to keep all of my files organized, is go to the top let's go ahead and just put in your name. Maybe you want to put in the date. And put some information about the file or the program. So you can say, this is part of a project involving a coin object. This game flips a... I'm sorry, this one flips 2 coins. And the first one to get 3 heads in a row wins. And then here, and this is helped me out quite a few times, if your files ever get separated, it might be helpful to know which ones are part of it. So in this case, you can say coin.java and then coinrace.java. Just make note that this is this file. And if you wanted to go ahead and include the other one, you could do that as well. So I'll just do that here, even though they technically are somewhat not related. So I'll do coincount.java. So I can take this and copy and paste it right at the top of each one of my files, and then just go ahead and change which file this pertains to. So in this case now we're in the coin object, so I'll say this file. And now later on, if you come back and you find one of these, you instantly know, okay, this file is coin, and the other files that I need are going to be coin race and then coin count. So let's put this in as well. And you can change this to reflect specifically what each one of these classes does in particular. So that covers the basics. In the next tutorial, we're actually going to go ahead and create a few more class files that all interact together to create a much larger program that does a lot more in detail. So thanks again for watching, and stay tuned for the next video.